uniformly distributed. Ngayon naman meron tayong concentrated live loads. Okay. So ano ba yung concentrated live loads na yan? It is actually a load, a single load applied at a certain point on a particular area in the building. Okay, it's not technically area kasi pag sinabi mong area, baka sabihin nilang uniformly distributed na yun. Okay, so parang applied to a particular point on the building na yung definition natin. So that's a concentrated live load. So floors, roofs, and other similar surfaces shall be designed to support the uniformly distributed live loads prescribed in section 4.3. That was I explained here, or the concentrated load in pounds or kilonewtons given in table 4.3.1. Okay, so yung table 4.3.1 natin, binibigay niya yung standard values ng uniformly distributed and ng concentrated. Okay, whichever produces the greater load effects. Unless otherwise specified, the indicated concentration shall be assumed to be uniformly distributed over an area 2.5 feet by 2.5 feet and shall be located so as to produce the maximum load effects in the members. Okay? Naka-specify dun sa table 4.3.1. Okay? Kasi doon sa specifications later on, makikita nyo, sabihin niya what type of occupancy, kung residential ba, mga sasabihin niya kung ano yung live load for per area sa ang tawag dito sa mga residential, mga ganyan. Depende doon sa occupancy. So, although yung table na nilagay ko doon is somewhat maliit lang guys kasi sobrang haba ng table. Okay? Sobrang haba ng table. Sobrang dami ng values doon. Parang in-snip ko na lang yung first and second part ng table. Although sobrang haba ng table. Later on naman, makikita niyo siya doon sa may ganun. Doon sa may ESCE. Okay? So, if walang specified, guys, na live loading for the particular type of occupancy, okay, yung concentrated live load natin, okay, shall be assumed to be uniformly distributed. Okay, so if we have live load, ko-convert natin siya into a uniformly distributed load, okay, and then yung area, okay, area of AOE nung concentrated live load na yon is actually 762 mm by 762 mm. Okay, so that's 2.5 feet by 2.5 feet. So, ilang metro yan, guys? Okay. Ilang metro ito? So, almost 1 meter ba ito? Tama. Almost 1. So, mga 0.76 meters. Okay, so wala pang isang metro. Okay, so yung concentrated live load ninyo should be directed towards this area. So that's 0.76 meters by 0.76 meters. Okay, kung walang naka-specify sa table 3, table 4.3-1. Okay. So next, meron tayong loads on handrail, guardrail, grab bar, and vehicle barrier systems and on fixed ladders. Okay, so alam natin kung ano yung pagkakaiba ng handrail, guardrail, grab bar, mga ganyan. So sa handrail and guardrail systems natin, yung handrail and guardrail systems shall be designed to resist a single concentrated load of 200 pounds or 0.89 kilonewton applied in any direction at any point on the handrail or top rail to produce the maximum load effect on the element being considered and to transfer this load through the supports to the structure. Okay, so yung live load natin sa handrail or sa guardrail, okay, so a concentrated load lang siya. So apply natin siya at any direction or any point, okay, along the handrail or the guardrail, okay, whichever will produce the maximum effect. Okay, so kung saan man ang tawag dito, kung saan man saan nyo naman ilagay nyo yung concentrated live load na yun at some point, maybe sa top ng handrail, okay, sa top ng handrail which will create, kumbaga, maximum loading, mga ganyan. So, doon natin ilalagay, guys, yung 0.89 kilonewton. Okay? So, meron din naman tayong uniform load naman sa mga handrails and guardrails. Okay? It should be designed to resist a load of 50 pounds per feet. Okay? Or that's 0.73 kilonewton per meter. applied in any direction along the handrail or top rail, and to transfer this load through the supports of the structure. This load need not be assumed to act concurrently with the concentrated load specified in section 4.5.1. Okay, so when we say concurrently, it doesn't mean na sabay sila mag-act. Okay, at the same instance, mag-act yung live load natin na concentrated and uniform. Okay, so it could be na mauuna muna yung 0.73, okay, kilonewton per meter, and then followed by the 0.89. Okay, pero according to the code, you can use either of the two, whichever produces the maximum load effect. Okay, so you can do like a single loading lang, a single concentrated load, or a uniform load lang. Okay, so apply nyo lang siya doon sa handrail and guardrail systems natin, doon sa may hawakan mismo. Okay, pero in practice, guys, I don't think I've never seen someone actually putting a live load or a uniform loading in a handrail. Okay? Never pa akong nakakita ng plano na nag-compute sila ng live load for handrail and guardrail systems, guys. Okay? To be honest lang, okay? Based on my experience, wala pa ako nakita nag-compute ng live loading ng mga ganyan. Okay, basta nilagay na lang nila doon. Okay, basta yung architect dinesign niya na ganito, or this is according to ganun, this is according to anong tawag doon, this is according to the building code, this is anthropometrics, mga ganyan. Ito yung standard height niya, mga ganun, kineme. So, parang wala talagang ganun. Wala talaga akong nakita nag-compute ng mga ganyan. Okay, so moving on, we have exemptions. Okay, so we have exemptions in the following. Okay, so of course, the uniform load need not be considered for the following occupancies. Okay, so meron tayong tawag dito, exemptions. We don't need a uniform loading anymore if yung occupancy naman natin is 1 and 2 family dwellings lang. And kung yung inyong structure is factory, industrial, and storage occupancies in areas that are not accessible to the public and that serve an occupant load not greater than 50. Okay, so kung meron tayong mga exemptions, okay, so 1 and 2 family dwellings, mga ganyan, so maybe you don't need live loads anymore kapag sa handrails if yung inyong bahay is bungalow lang, ganyan, okay, so from pagdalawang pamilya lang, mga ganon. So, factory din, of course, siguro kasi sa factory, they barely use, okay? Siguro ito yung reason behind that. They barely use the CR, mga ganyan. Or maybe kasi yung mga factories natin, some of it are actually designed not entirely for a live loading kasi most of the structures are connected to the building, especially yung mga manufacturing tawag dito, factories, and then yung mga anong tawag dito. Have you ever been to SNR? Sino nang nakapunta ng SNR, guys? Wala pang nakapunta ng SNR kasi yung SNR kasi is somewhat para siyang shopping center, pero yung shopping center kasi na yon is actually sobrang laki niya, guys. Okay, parang wholesale kasi siya. Okay. So membership shopping kasi yon. Pagpasok niyo dun sa loob niya, para siyang storage, guys. Na patong-patong lahat yung mga gano'n. Sobrang laki niya talaga niya, I swear. Sobrang laki niya, and then sa loob, patong-patong yung mga mabibili, mga gano'n. Then, ayun. So, walang masyadong stairs, ganun guys doon. Walang stairs and then walang handrails kasi nga it's like a grocery shop. Pero sobrang massive na grocery shop na para siyang storage, ganun. So, it serves as well as storage, ganyan. So, doon wala talagang handrails, mga ganun. It's like an open space pero parang yung loob niya is a building of a lot of goods, mga ganyan. Okay. So if yung occupancy, occupancy if is not greater than 50, so there are only, this actually pertains to the number of heads inside the factory or the industrial plant. Okay, so if the number of heads in that particular factory is not greater than 50, then you don't need to have yung inyong handrails and guardrails na uniform loading. Okay? So ito yung table 4.3-1 natin. Kineme. Mga types of occupancy, meron tayong apartments, access floor systems, armories, balconies, ganyan. So meron tayong uniform live load na, ito guys ha, yung prescribe ha, yung prescribe na uniform live load natin. So, meron tayong 50 pounds per square foot. And yung katabi niya guys na close and open parenthesis, that is in terms of the SI unit. So that's 2.40 kilonewton per m squared. Okay, that is for the gross floor area guys ha. That's for the gross floor area. Okay, so ano ba yung gross floor area na tinatawag na yan? Ano yung gross floor area? Anyone? What is a gross floor area? Anyone? What is the gross floor area? Ini-score na to. Hala, hindi nyo alam ang gross floor area, guys. What is the gross floor area? Oh my goodness. Okay. Guys, when you say gross floor area, that is from the exterior wall, okay, exterior to exterior part of the building. For example, ito nga, i-share ko na nga lang to. Okay. Okay. Ayun. So, if this is your building floor plan, sabihin na lang natin ito yung floor plan ninyo, ganyan. Ito yung wall. Ayan. Ito yung exterior, guys, ha, ng wall. Ayan. So, parang ganyan siya. So, yung gross floor area nyo will be, ito guys, from here. Yan yung inyong gross floor area. Okay, that is considered as your gross gross floor area. Okay, so that's from the exterior of the building, measured from exterior to exterior of the building. So that's your gross floor area. Okay, so what dito mo i-apply yung inyong loading. As you can see guys, diba yung meron tayong mga excess dyan, that is part of the gross floor area. Okay, so that's part of your gross floor area. Meron din tayong tinatawag na leasable, mga ganon, tapos net area, mga ganon. So yung net area naman, ang net area natin, yung part lang na yung space lang within the building. Okay, within the building and outside of the building na rin. Isama na natin pati yung lot, okay, lot area. So yung inyong net area is somewhat yung pwedeng i-occupy ng tao, okay? So hindi kasama yung hindi na kasama yung wall, okay? Hindi na kasama yung wall, but itong mga nandito lang, okay? Yung pwede lang yung accessible lang sa mga tao, okay? Pwedeng lagyan ng gamit. Yun lang yung tinatawag nating net area, okay? So going back, mute. Ayan. So going back, these are our prescribed distributed live loads. So meron tayong different types of occupancy or use, and then meron din tayong uniform, and then meron din tayong concentrated. As you can see, yung ibang areas dito, wala silang concentrated na live load. Okay? For office and computer use, meron tayong both uniform live loading. Okay? Ito. So, yung concentrated load niya, yung concentrated load niya, ito. Okay? So, meron din tayong tinatawag na live load reduction permitted, yes or no lang. It depends on the section. Okay, so according to 4.7.2, pwede natin i-reduce itong live load na to. Okay, yung uniform live load. Meron din tayong multiple story live load reduction. Okay, so of course, we can also reduce that in accordance with section 4.7.2. Okay, so yun yung table 4.3-1 natin. Later on, mahaba kasi to guys, sobrang haba nito. It depends really on the type of occupancy or the usage of that particular area or that particular. So later on, when you do your case study or your design, ito yung gagamitin ninyong live loads. Okay? And then concentrated na live loads. Okay? So, ito yung iba, dining rooms, mga gano'n. So, meron din tayo dito guys, yung helipad. Meron tayong handrails, guards. Then, meron tayong hospitals. So, meron tayong reduction dyan. And meron din tayong live loading. Some of the live loads in here are not really applied. Pero, hindi niya in-specify. Pero meron tayong mga sections. Okay? Sections to consider for the concentrated live loading. Okay? So, the guardrail system component loads. Okay, balusters, panel fillers, and guardrail infill components, including all rails except the handrail and the top rail, shall be designed to resist a horizontally applied normal load of 50 pounds or 0.22 kilonewton on an area not to exceed 12 inches by 12 inches, including openings and space in between the rails and located so the maximum load effects reactions due to this loading. Okay. Reactions due to this loading are not required to be superimposed with the loads specified in sections 4.3 and 4.5.1.1. Okay? So yung balusters natin guys, kapag meron kayong stairs, okay? Pansinin niyo yung stairs niyo, parang meron siya mga poste, yung poste siya na maliliit. Okay? So parang naka siya, spaced, okay? May space yung guardrails, yung baluster. So yung poste ng handrail ninyo, yung maliliit na poste, okay? Yun yung tinatawag natin balusters, okay? And according to the code, dapat daw yung ating baluster, it should be designed to resist a horizontally applied normal load, okay, of 0.22 kilonewton per kilonewton on an area 12 inches by 12 inches, okay? So yung 12 inches by 12 inches na yan, regardless kung yung balusters niyo is may butas, i-apply nyo pa rin yung 0.22 kilonewton na concentrated na live load. Okay, pero this will not be concentrated once it is applied kasi yung area, the concentrated live load is actually applied at area of 12 inches by 12 inches. Okay, in actual, it's not concentrated anymore kasi nga meron siyang particular area, okay, na ina-applyan. Okay, so yung application ng load natin is actually normal to the baluster. Okay, so wag lang nating isama yung mismong handrail, okay, or yung top rail ng ating system. Okay, just the balusters and panel fillers lang. Okay, so iba pa kasi yung sa may guard, yung sa may mga handrail natin. Okay, so yung grab bar systems naman, okay, shall be designed to resist a single concentrated load of 1.11 kilonewton applied in any direction at any point on the grab bar to produce the maximum load effect. So hindi ini-specify ng 4.5.2 kung saan nyo ilalagay yung concentrated live load. But rather, it is up to your practice or your decision and maybe your authority kung saan siya ilalagay. Nagdedepende yan kung saan mas malakas or saan mas mahina yung particular part ng grab bar system natin. Okay? So, mas abuti siguro kung i-apply nyo yung live load na ito, itong concentrated live load na ito into the weak point of your grab bar system. Okay? Para kahit paano, kasi yun magiging critical guys, yun magiging critical. Para kung kahit paano is ma-foreseen agad natin what will be the best design, okay? In order for this particular weak spot to overcome that 1.11 kilonewton effect. Okay? So yun yung mga grab bar system, mga minimum, okay, design na grab bar system natin. Okay. Next is vehicle barrier systems. We will not really go deeper into this particular type of loading, okay? Kasi this only like applies to malls, mga ganyan. Pero hindi ko naman pag-design malls, guys. Okay, it's just a 2-span, mga ganun siguro, or like 3-span, 2-story building, ganun. Depende sa inyo kung anong mabilis. Okay, so yung pasadahan na natin to, pero let me just read na lang. Vehicle barrier systems for passenger vehicles shall be designed to resist a single load of 6,000 pounds or 26.70 kilonewton applied horizontally in any direction to the barrier system and shall have anchorage or attachments capable of transferring this load to the structure. For design of the system, the load shall be assumed to act at heights between 1 feet and 6 inches and 2 feet and 3 inches, okay, above the floor or ramp surface located to produce the maximum load effects. The load shall be applied on an area not to exceed 12 inches by 12 inches. This load is not required to act concurrently with any handrail or guardrail system loadings specified in section 4.5.1, and the vehicle barrier systems in garages accommodating trucks and buses shall be redesigned in accordance with AASHTO LRFD bridge design specification. So yung vehicle barrier system natin, meron silang particular code lapa, okay? The separate code for them, okay? Especially if the vehicle is specific to, or the system is actually specific to trucks and buses lang. So that will be the AASHTO LRFD bridge design specifications. Anyway, we won't be going in depth, okay, through this particular barrier system effect na ito. Okay, kasi I won't allow you naman, or I won't require you to have the parking, okay, parking on the roof deck, mga ganyan. So hindi ko na kayo i-require ng ganyan. So stick na lang tayo dun sa simple na design natin ng framing. Okay, no more parking, okay, sa roof deck. Okay. Then meron tayong fixed ladders, guys. Tulad nga na sinabi ko, yung fixed ladders kanina, these are actually access points, maybe fire exit, mga ganyan. Sa fire exit natin, hindi naman laging stairs yan. Okay? Some of it are actually fixed ladders. So yung mga ladders na yan ay anchored through a wall or through the wall. Okay? And then, pag may fire, okay, especially kung walang budget yung building or in accordance with the building code, fixed ladder na lang po yung gagamitin nila. Okay? So yung fixed ladders natin with rungs shall be designed to resist a single concentrated load of 300 pounds applied at any point to produce the maximum load effect on the element being considered. So the number and position of additional concentrated live load units shall be a minimum of 1 unit of 300 pounds for every 10 feet of ladder height. Okay, and then where rails of fixed ladder extend above the floor or platform at the top of the ladder, each side rail extension shall be designed to resist a single concentrated live load of 100 pounds, or that's 0.445 kilonewton, applied in any direction at any height up to the top of the side rail extension. Okay, ships ladders with threads instead of rungs shall be designed to resist the stair rods given in table 4.3-1. Okay. Sometimes kasi yung ladder natin, guys, medyo naka-protrude siya. Okay, medyo naka-protrude. Okay, from the wall itself. So yung mga protrusion na yan ng ating ladders, kino-consider natin yan for the design of the ladder itself. So yung minimum na loading natin, okay, so it should be 300 pounds for every 10 feet, okay, for every 10 feet of the ladder. So if yung ladder ninyo is greater than, or maybe yung ladder ninyo ang haba lang niya is 10 feet, okay, so mga 3 meters, ganyan lang, you just need to have like one unit of, or there's only one concentrated live load, okay, that's 1.33. Okay, 1.33. Pero yung 1.33 na yan will act on the 10 feet, okay, for every 10 feet, okay. So that 1.33 will be transformed into uniformly distributed na live load. So that's 1.33 for every 10 feet, okay. So what if it is actually 30 feet? Okay, so that would be 1.33 times 3. Okay, kasi that's 30 over 10 multiplied by 1.33. So there should be at least 1.33 concentrated live load for every 10 feet of height. Okay, otherwise specified, okay, especially for ship's ladders, okay, may exemption tayo. So kung meron silang threads instead of rungs, okay, try nyo lang siya i-google, guys, kung ano yung threads and rungs. It shall be designed, okay, in accordance with table 4.3-1. Okay. So meron tayong impact loads naman, guys. Ano ba itong mga impact loads na to? Okay. So yung impact loads other than the specified live loads in sections 4.3 to 4.1 will be assumed, okay, to include adequate allowance for ordinary impact conditions. So yung mga impact loading na yan, something that causes vibration through the system, that is what we call impact loading. Okay, though impact loadings are, though sinabi ko kanina na the loadings that actually cause vibration on the object are called impact loadings, this is different from seismic loading, guys, because seismic loadings actually causes as well impact loadings, or rather vibration on the system. It is not under impact loads. Okay, so different provision tayo sa seismic loading. Okay, so bigyan natin ng konting allowance for impact loading. For example, kasi yung mga materials natin sa roof, okay, minsan nababagsak ng officer. Okay, syempre we have to take note na may effect din yung mga pagbagsak ng mga materials sa bubong natin, mga ganyan. Okay, so meron tayong provisions in here. So meron din tayong elevators. Okay, these are as well causes impact loadings. Okay, so all elements subject to dynamic loads from elevator shall be designed for impact loads and deflection limits prescribed by ASME A17. Okay, so dito hindi niya in-specify, guys, kung ano yung particular impact loading. Okay, particular na impact loading ng elevator, but rather nasa separate siya na code. Okay, and that's ASME A17. For machinery naman, for the purpose of design, the weight of the machinery and moving load shall be increased as follows to allow for impact. Okay, for light machinery, shaft or motor driven, 20%. Okay, so multiply lang tayo ng 1.20 doon sa weight ng ating machinery. That will now account for the impact loading of that particular machinery. Okay, and then we have here as well reciprocating machinery or power-driven units, 50% naman. Okay, so yung mga power-driven units na yan, yung tinatawag yung mga generator. Okay, malalaki kasi yung mga generator natin. Okay, so multiply tayo ng 1.5. Okay, and that will now account for the impact loading of that particular power-driven unit. Okay, so all percentages shall be increased where specified by the manufacturer. So it really depends. Pwede tayo mag-increase, guys, ng percentage ng impact loading. Okay, that depends on the specifications of the manufacturer. So yung diba meron yung mga ganun, mga generator, meron yung info na booklet. So nandun, guys, kung ano yung mga percentage, yung info na yun, it contains as well yung percentage ng impact loading niya. Okay? Then we have element supporting hoist or facade access and building maintenance equipment. So structural elements that support hoist or facade and building maintenance equipment shall be designed for a live load of 2.5 times the rated load of the hoist or the stall load of the hoist, whichever is larger. Okay, so this the soft weight will be multiplied by 2.5. Okay, and it depends as well kung ano yung specification ng manufacturer. Okay, for example, the ang tawag dito, the manufacturer or the supporting hoist or maintenance building maintenance equipment sa kanyang specification 3.5. Okay, 3.5 yung tawag dito, yung amplification variable. Okay, so syempre, instead of using 2.5, okay, instead of multiplying the live load 2.5, we have to multiply it by 3.5 kasi yung pipiliin mo lagi is yung larger. Okay, pero in here kasi sa code minimum of 2.5 yan. Okay, pero whichever is larger, yun yung i-multiply natin. Okay, then meron din tayong fall arrest and lifeline anchorages. Okay, so yung sa mga ganyan naman, designed for a live load of 13.8. Okay, 13.8 for each attached lifeline in every direction, and a fall arrest load may be applied. Okay, so yung mga ganito, guys, lifeline anchorages, for example, anong tawag dito? Yung mga, meron kasi tayo, guys, di ba, sa construction, meron tayong pinagkakabitan ng mga ganun natin, mga parang chain para hindi tayo malaglag, especially pag nagkakabit ka ng windows, mga ganun sa matataas na building. Meron kang pinagkakabitan doon. Yung iba nga sa scaffolding nilang kinakabit, pero that's very dangerous. Okay? So yung mga fall arrest and lifeline anchorages, yun yung tawag natin doon, fall arrest and lifeline anchorages. So doon mo ikakabit, guys, yung parang belt mo, and then ihahang ka nila to make kabit-kabit of the window, mga ganyan. So yung mga yun, dinidesign din natin yun. Okay? So each of those are actually designed to resist a live load of 13.8 kilonewton. Tingnan mo yun, napakalaki ng allowance natin for the anchorage. Okay, so that's 13.8. Okay, for each attached lifeline in every direction that a fault arrest load may be applied. Okay, so for example, the desired number of lifeline for that particular anchorages is tatlo. So that's 13.8 times 3. Okay, so ganun guys yung computation niya. 13.8 times 3. Depende kung ilan yung capacity nung anchorage na yun. So for example, kasi kaya tayo may safety engineer. So the safety engineer will specify, there should only be tatlong lifeline in here, in this particular anchor. Okay? So, hindi kayo pwede mag-exceed ng tatlo. Kasi if nag-exceed kayo ng tatlo, 5 na kayo dyan nakatali, well, babagsak yan. Or, yun nga, there's a big possibility na malaglag kayong lahat, mag-fail yung system. So, you have to minimize, okay? You have to minimize the number of lifeline connected to that particular anchorage. So that would be 13.8 times 3. Depende kung ilang tao yung gusto nyong magtali or maglagay ng tali nila doon or ng chain nila para hindi sila malaglag. Okay? So let's proceed to reduction in uniform live load. So we can reduce the minimum uniformly distributed live loads, okay, in table 4.3-1 in order for us to make or to save or make the building more economic. Okay, so we're trying to as much as possible kasi we're trying to reduce the cost of construction. Okay, so if we just stick to the uniform live loads specified in the code, although 1-story or like 2-story lang naman yung building mo, well, it will not be cheaper. Okay, it will not be cheaper for you. Kaya meron tayong tinatawag na reduction in the uniform live load. Okay, so ano ba itong mga reduction to the uniform live load na ito? Okay. So in here, except for roof uniform live loads, all other minimum uniformly distributed live loads, LO, okay, in table 4.3-1 are permitted to be reduced in accordance with the requirements of sections 4.7.2 and 4.7.6. Okay? So, yung mga uniform live loads natin, roof uniform live loads, hindi separate yung kanila. Separate yung kanilang tawag doon.
Di ba kwarto?
Okay. Sorry about that. Except for uniform live loads, going back, let me repeat that. Except for uniform live loads, meron tayong reduction to the uniform live loads other than the roof. Okay? So, meron tayong permitted or meron tayong formula for the reduction. It really depends, guys, kung pwede ba natin siyang i-reduce or not. Okay? So, in here, subject to the limitations of sections 4.7.3 through 4.7.6, members for which a value of KLL80 is 400 square feet. Okay? So, later on, nasa 4.7.2 pa lang kasi tayo. Okay? So, yung 4.7.3 through 4.7.6, then natin makikita later on yung limitations. Okay? So, kung yung member mo with a value of KLL or 80, which is 400 square feet, okay, or 37.16 square meters or more, pwede natin siyang i-reduce, okay, to a live load in accordance with this particular formula. Okay? Yung LO mo dyan, guys, that is your original live load or the minimum live load specified in table 4.3-1. And then, itong first equation mo is actually in terms of a British unit. And then, yung sa baba is yung SI unit mo. Okay, so that's 0.25 plus 4.57 over KLL, the square root of KL over 80. Ano itong KLL over 80 na yan? Okay, so yung inyong KLL over 80, yung KLL nyo first is the live load element factor. Okay, so ito yung element factor ninyo. If it is an interior column, exterior columns with cantilever. It depends on the plan, okay? It depends on the plan. So is it, does it just contain interior columns, okay? Does it just contain corner columns? It depends on the tributary area, okay, that you are considering, okay? Anyone, what is a tributary area again? Anyone from the group who knows what a tributary area, or aalala niyo pa ba kung ano ang tributary area? So yung 80 natin doon is actually a tributary area. Okay? So yung KLL, okay, K sub LL is actually the live load element factor. Pero ano yung tributary area natin, guys? Ano yung ibig sabihin natin when we say the tributary area? Anyone from the group who can share what a tributary area is? Wala may alam kung ang tributary area, guys. Wala talagang gusto mag-share, guys, kung anong tributary area. Okay. Sige, i-kwen ko na lang siya. I-illustrate ko na lang kung ano yung tributary area. Okay, so let me just share my screen again. Okay. So dito, balik tayo dito. For example, you have this particular plan. Rather, let's use the black ink na lang. You have this particular plan, guys. Okay. So you have this particular plan. Ayan. So assuming this is your plan. Ayan. Sabihin na lang natin straight yan na. Okay, kahit hindi na siya straight. Okay. For the sake of demonstration na lang. Ayan. So for example, ayan yung plano ninyo. Sabihin din natin may beam na din dito. Okay. Beam na yan dito. Okay. Ayan. So yung tributary area natin, guys, that is actually the area in which the structural element is supporting or supporting. Okay? So in this particular example, this beam in here, okay, itong beam natin dito here, in the one in the middle, is actually supporting a tributary area. Okay? Maybe the tributary area is here somewhere. Ayan. So, ito yung area na sinusuportahan ng beam na yan. Okay? Ayan. Ayan. So, whatever is the area supported by that structural element, that is what we call the tributary area. Now, yung ibang structural elements din dito, meron din silang sinusuportahan na tributary area. For example, itong exterior beams natin, that is actually supporting somewhat this particular area as well. Although hindi naman, meron tayong computation for the tributary area, guys, ha? Meron tayong computation for the tributary area. It depends on which structural element are you considering. Especially, ang medyo complicated lang na computation is yung sa slab. Okay? So, ito yung mga tributary area. Ayan. So meron din itong particular side na ito, this one, it's supporting this particular area in here. Okay, so kinikerry niya yan. And then itong particular beam din dito, it's actually carrying this one as well. Okay, so ayan. So those are your tributary areas. Whatever that particular area or whatever that particular structure element is supporting, that is now your tributary area. Okay. Pero hindi magagaranti guys ha. Hindi magagaranti na sure paano din gapin itong nasa gitna. Sino din magka-carry niyan? Okay. Sino magka-carry niyan? Okay. May mga instances kasi guys na ganyan yung particular na illustration mo for the tributary area. Now, yung mga ganito, yung mga ganyan na hindi kasama sa tributary area ng beams and columns, okay? By the way, the column as well is supporting somewhat maybe. So actually itong particular area na to, that's the tributary area. Okay? Kung may kadugtong pa yan. So, yung nasa gitna, guys, na it's not supported by the beam or the column, okay, that is now considered as the tributary area of the slab, one of the tributary area of the slab. Okay, it depends kung one-way or two-way slab pa yan. So, that's your tributary area. Okay. So, going back to the presentation, okay. So, pwede natin i-reduce yung ating live load and dead load, okay, in accordance with this particular section on the ASCE, okay. And first step is actually to determine your the product of your KL and your AP. Okay, so your KL is the live load element factor, wherein AP is your tributary area. Okay, values in here depends kung, okay, so check nyo lang yan later. So yung ating L, oops. Yung ating M is the reduced live load na in the formula. Okay, tandaan nyo guys ha, hindi yung dalawang formula yung gagamitin ninyo. So ang lagi-lagi natin gagamitin is yung second. Okay? Yung second, kasi that's the SI unit. So yung L na rin dito is the reduced design live load per M squared of area. Okay, supported by the member. And yung LO natin is yung unreduced, which is found on table 4.3 dash 1. Okay? Okay. So yung L natin, meron tayong tawag dito, conditions, okay, for the L as well. Hindi porket gumamit tayo ng formula, yun na yung gagamitin nating L. Okay? So, the condition here is that yung L natin should not be less than 0.50 LO. Okay? For members supporting one floor, and L shall not be less than 0.40 for members supporting two or more floors. Okay? So, even though kasi guys, meron tayong particular elevation plan. Okay? Kung ako particular. Siguro, Miss Laika, bilangin mo kung ilang beses na ako nagsabi ng particular. I-note mo na yun. Okay? So, meron tayong mga plans guys na yung column nila abot lang ng first floor pero hindi na siya aabot ng second floor, mga ganyan. Tapos meron din dun sa plan na yon, yung meron ding ibang columns na abot na ng second floor, third floor, mga ganyan. Tapos meron kumbaga meron yung columns na from ground to the top, pero yung iba naman meron from ground to the first floor lang. Okay? So kung yung column ninyo or the structural member or the support is actually carrying just one floor, okay? For example, nasa ground floor lang siya, it just actually carries one floor. Yung live load ninyo shall not be less than 0.40. Okay? 0.40. Uh, rather, it's 0.50. Okay? Should not be less than 0.50. Pero yung for columns naman are for supporting members na greater than one story yung sinusupport niya. Well, your live load or your reduced live load should not be less than 0.40 of the specified live uniformly distributed load or concentrated load on table for the 4.3-1. Okay? Okay, so meron din tayong heavy live loads, guys. Anyway, guys, this is blah blah, more on blah blah ito kasi it's actually just the introduction. Okay. So meron tayong live loads that exceed 100 pounds per square feet. Okay, 4.79 kilonewton per m squared shall not be reduced. Okay, so if your live load is actually exceeding, okay, so yung live load ninyo, meron ng exemptions. Okay, so kung yung live load ninyo is actually upon computation, okay, wala pang reduction to ha, upon computation is greater than 4.79 kilonewtons per square meter, you should not reduce it anymore. Okay, you shouldn't reduce it anymore. Okay, except for live loads for members supporting 2 or more floors. Okay, so kung yung structural member nyo is actually supporting 2 or more floors, okay, that particular that 4.79 kilonewton per square meter can be reduced to a maximum of 20%. Okay, but the reduced live load shall not be less than L as calculated in 4.7.2. So if you're going to reduce this 4.79 by 20%, make sure to go back to the formula. Okay, to the formula, you have to check always if yung reduction ba is less than this a value upon application of the formula. So if you have a reduced 4.79 by 20%, okay, before you put there the final value of the reduced live load, you have to check kung yung live load ba na yon is actually greater or less than this one. Okay? If that reduced live load is less than this prescribed in here by this formula, you have to use itong formula na ito. Okay? So L equals LO. Okay? You will have to use that. It's not permitted to be less than L as calculated by that formula. Okay? Now, let's proceed to the passenger vehicle garages. Okay, so for passenger vehicle garages naman, the live load shall not be reduced in passenger vehicle garages. Okay, so no need for you to reduce, okay, the live loads, okay, for passenger vehicle garages. May exemption na naman tayo. If the live loads for members supporting 2 or more floors are permitted to be reduced a maximum of 20%. Okay, so parang this is similar to the exception in 4.7.3. Okay, 4.7.3. Okay, pero same lang din yung process. Okay, whatever is your computed live load, okay, whatever is your computed live load for the passenger vehicle garage, okay, pwede nyo siyang i-reduce by a maximum of 20%. Okay, pwede siyang i-reduce by a maximum of 20%. Okay, for members supporting 2 or more floors. Okay, so yan yun. Pero again, yung inyong reduction, okay, yung inyong reduction should be in accordance with section 4.7.2 equation. Okay? So, similar lang talaga siya dito sa 4.7.3 exemption. Okay? So, 4.7.5, live loads shall not be reduced in assembly uses. Okay? So, lahat ng live loads na assembled in nature, okay, so, going back, okay, wait lang, nauuhaw ako guys. Pwedeng uminom muna. Na-dry na yung lalamunan ko. Ang hirap pala ng ganito. 3 hours ka nagsasalita. Oh my God. Okay. So, for machineries that are assembled in nature, okay, live loads shall not be reduced in assembly uses. Okay, so you should never ever reduce machineries that are being assembled on the spot, especially if it is a live load. Okay, kasi yung effect niya, there's a tendency na mako-compromise yung design. Okay? So, meron din tayong limitations for one-way slabs. Okay? One-way slabs and two-way slabs. Guys, what do one-way slab and two-way slab? Have you ever guys encountered one-way slab and two-way slab na term during your concrete na ganon? Reinforced concrete, one-way slab and two-way slab. Have you encountered that? Wala pa kayo na-encounter guys na term na one-way slab and two-way slab?
Na-encounter na, sir.
Okay, what's the difference between one-way slab and two-way slab? The difference between one-way slab and two-way slab, guys. Anyone who has an idea what's the difference between one-way slab and two-way slab? Okay. Di ba guys, medyo critical ang design natin kapag two-way slab, ganon. Tapos pag one-way slab lang naman, very easy lang yung design kapag ini-staan ninyo. Pero, ano bang difference ng one-way slab and two-way slab? Sige, i-illustrate ko na lang siguro. Okay, illustrate na lang natin ulit. Okay. So, ganun ha, bear with me kung hindi kagandahan yung drawing ko. Okay. Kaya ako nag-shift from architecture to civil kasi hindi ako magaling mag-drawing. Okay. So, one-way slab, guys, if this is your slab, okay, ito yung slab ninyo. Ayan. So, yan yung slab ninyo ha. Ayan. One-way slab are slabs that are supported by beams at one side or maybe one opposite side only. Okay. So if this is your slab, we call this one-way slab if your beam is somewhat like this. Okay. It is just located on two sides of the slab itself. Okay. So parang ganyan lang siya. Ganyan lang yung support. Okay? So this is your beam. Okay? And this is now your slab. Okay? So that is one-way slab. Okay? For two-way naman, okay, ang mangyayari is that, okay, ang floor plan nitong one-way, ganito siya. Okay? Floor plan nito ha. Ito yung slab mismo. Yan. So, ito yung beam. Okay. Ayan. So, ganyan. That's one-way slab, okay? Although yung beam can be at the can be located or offset, okay? Pwede mong siyang i-offset. Pwede yung slab, yung edge ng slab is located at the center of the beam. Ngayon, that's one-way slab. Ang two-way slab naman, ang kinaibahan niya lang sa one-way slab is that lahat ng sides is actually supported by a beam. Okay. So kung yan yung slab mo, ay ganyan siya. Okay. So may beam here, may beam in here. Okay. Ganyan. Tapos meron din ulit beam dito. Okay. So ganyan siya. Kumbaga, somewhat may beam ulit dyan. Okay. So kung floor plan yan is ganito. Okay. May beam dyan, may beam here, may beam there, and may beam dyan. Okay? So that is your two-way slab. Pag one-way, okay, dalawang side lang yung may support na beam. Pag two-way naman, yung apat na sides yung merong beam. Okay? So most of our design in construction, okay, lagi tayong nagto-two-way. Okay? Bakit tayo nagto-two-way lagi? Okay? Kasi sinasabi nga nila, it really depends on the loading conditions. So parang mas guaranteed kasi na safe. Although if you want it to be more economical, okay, you have to test if it is good for one way. Pero if you're more onto safety than economy, okay, pero dapat kasi balance lang. If you're more into safety and economy, you should always use a two-way slab. Anyway, ang predominant or prevalent na used na slab, okay, is yung two-way. Okay, so yan yung difference between the one-way and the two-way slab. Okay, so yun lang naman, guys. Okay. Now, going back, let me just resume. Okay. Meron tayong condition din, guys, okay, for okay, wala na yung presentation. Ayan. So, meron tayong limitations, guys, okay, for one-way slab naman. That's for, ang tawag dito, the general purpose ng ganun. General purpose ng nga ba to ulit? Reduction, okay? So the tributary AP for one-way slab shall not exceed an area defined by the slab span times a width normal to the span of 1.5 times the slab span. Ano daw? Ganun daw. Naloka kayo. Okay. So, yung limitation niyan, tributary area. Siyempre, meron tayong tributary area. Okay? Hindi ko na ipapakita kung paano, guys, sa complete yung tributary area ng inyong kung paano i-compute yung mga tributary area, okay? Kasi in the software, more on software kasi tayo, okay? So hindi naman tayo magma-manual computation, okay? So yung tributary area kanina na pinakita ko, okay, kung yung one-way slab ninyo, okay, yung tributary area ng one-way slab, okay, hindi siya lumagpas sa area defined by the slab span. Okay, ano ba yung slab span na yan? Okay, so yung slab span na yan, that's the measurement between column to column or beam to beam. Okay, that's the slab span multiplied by a width normal to the span. Okay, so parang length multiplied by the width yan, guys. Okay, medyo kinuha nila, medyo technical lang yung term ng 4.7.6. Pero in layman's term, mga ganyan, that's just equal to the span length, okay, the beam to beam or column to column length multiplied by the width of that particular slab. Okay, so yan yung 4.7.6. Okay, Yung width nga lang is i-multiply mo ng 1.5 times the slab span. Okay? So, yun yung magiging tawag dito, yung magiging basis mo, okay? For the reduction. For one-way slab lang yan. Anyway, in some practices naman, yung tributary area talaga, guys, okay, never siyang nag-exceed ng slab span multiplied by 1.5 the slab span. Okay, so that's length multiplied by 1.5 of the length. Okay, kasi yung span, okay, yung length, i-multiply mo pa ng 1.5, mas malamang, mas malaki talaga yung value niyan. Okay? Pero yung tributary area na yan, yung area that is supported by that one-way slab alone, hindi talaga siya lumalagpas ng length multiplied by 1.5 the length of that slab. Okay? That's 4.7 points. Okay, so meron din naman tayong reduction of roof live loads. Ang dami-dami nating reduction. Okay, so kanina, this is just, we just talked about the reduction of live loads, okay, in terms of the uniformly distributed. Okay, so hindi natin sinama dito yung live loading. So, in general, the minimum uniformly distributed roof live loads, LO, in Table 4.3-1 are permitted to be reduced in accordance with the requirements of Section 4.8.2 and 4.8.3. Okay, so where your uniform live loads are, your uniform roof live loads are reduced to less than 20 pounds, okay, or that is actually 0.96 kilonewton per m squared in accordance with the section 4.8.2 and are applied to the design of structural members arranged so as to create continuity. The reduced roof live load shall be applied to adjacent spans or to alternate spans, whichever produces the greatest unfavorable load effect. Okay? Now, if nag-reduce tayo in accordance with 4.8.2, kasi may separate na calculation, guys. Okay, yung kanina, yung formula niya is for uniformly distributed live load lang, pero it doesn't include the roof. Ngayon, meron din tayong formula for the reduction of ang tawag dito, reduction for the roof live loads lang. So, separate ang provisions ng roof live loads sa uniformly distributed live loads. Okay? So, kapag yung reduction ninyo ng roof live loads is actually or equal to 0.96 kilonewton per square meter, okay? Yung inyong roof live load, okay, na na-reduce will be applied to the adjacent spans. Okay? So kung ano man yung inyong reduced na live load at that particular span, pwede niyo siyang i-copy paste sa mga katabi niyang span. Okay? Whichever produces the greatest unfavorable effect, regardless, as long as yung inyong plan or yung inyong may conditions din, guys. Syempre, yung characteristics ng slab, okay, ng beam, dapat pare-pareho at every span. Okay? Hindi kayo pwede mag-copy-paste ng live loading kung magkaiba naman yung size ng beam ninyo at sa exterior na gano'n. Exterior na span, mga ganyan, and sa interior na span. Okay? Hindi kayo pwede mag-copy-paste. Kailangan pare-pareho. There should be a uniformity among the structural elements. Okay? Mapaslab man, concrete, or column. Okay? So, yung reduced roof live load ninyo, okay, for that particular span of the roof, pwede nyo siyang i-copy. Okay? Pwede nyo siyang i-copy. Okay? Next is 4.2, ordinary roofs, awnings, and canopies. So, kung yung flat yan, okay, flat, pitch, and curved roofs, you know the types of roofs. You guys, do you know the types of roofing? Nakita nyo na ba? Or like, do you have an idea what are the types of roofing? Gable, mga ganon. You encountered that?
Yes, sir.
Okay. So, wala naman tayong problema sa mga types of roofing na yan. Okay. So, it depends. Pero ito kasi, kung ordinary flat, pitch, and curved roof lang siya, Okay? Kung ordinary flat, ang daming pumapasok na tao dito. Okay, ordinary flat pitch and curved roof lang or and awning canopies, pwede niyo siyang gamitan, okay, ng reduction specified in equation 4.8-1, okay? And other controlling combinations of loads naman. So, specified siya sa chapter 2. Pero hindi na kasi natin pinasadahan, guys. Ang pinasadahan lang natin is yung load combination. So, yung chapter 2 kasi, it gives a more in-depth discussion about the load combinations, okay? So whatever is the load combination appropriate to the design of this roof, okay? Yun yung gagamitin yung roof, or rather the load combination that you're going to use. Pero sa reduction ng live load, mag-stick tayo sa equation 4.8-1, okay? So, gagamit tayo, okay, ng minimum live load na 0.58 for other structures. Pero otherwise declared in this section or this chapter of the ASCE, gagamit kayo ng roof live load na 12 pounds per square foot. Okay? So, computed yung roof live load natin. Okay? As long as the standard values are stated in this chapter. Pero pag walang naka-state na chapter or walang naka-state na specific na roof live load, ang gagamitin natin na minimum roof live load ay 0.58 kilonewton per square meter. Okay. So, ito na yung formula natin, guys, for reduction ng roof live load. Okay? So, meron tayong LO multiplied by R1 and R2. Okay? Where LR should be greater than or equal to 20, greater than or equal to 12, but less than or equal to 20. Okay? That is for the British unit. Pero kapag in terms of SI naman, we have LR should be greater than or equal to 0.58 but less than or equal to 0.96. Okay? So, yung LR natin, that's the reduced live load in terms of square meter of horizontal projection supported by the member, and LO is the unreduced design roof. When we say horizontal projection, guys, how do you apply a horizontal projection of the roof? Okay, so demonstrate natin ulit. Let me illustrate pala. Sorry, demonstrate ulit. Let me illustrate kung paano yung horizontal projection ng live load niya. Anyway, these are just illustrations lang naman. Okay. So, if you can see the screen already, at kunyari, ito yung roof natin. Okay, very typical roof. Okay, ganyan, roofing. Okay, tapos yung inyong purlins, mga ganyan, ito siya. So, ang application ng loading natin is somewhat, okay. Do you believe ganito, guys, ang application ng loading for the roof? Do you believe ganyan ang application ng loading for the roof? Is that, yes, is that the proper application of the loading in terms of the roof?
Yes, sir.
Sure kayo? Sure na? Okay, guys. When we were reviewing, actually, ang application ng RoofNet, all this time we thought that this is actually the application of the Roof Live Load. Pero in terms of the code, ang application para ng Roof Live Load is somewhat like this. Ganyan. Okay. Now, if you are going to transform that, okay, if you are going to transform that or apply it to the roof, magiging ganito na yung one guys. Magiging ganito na yung itsura ng live load. Ganyan. Ayan. So, this is how you are going to apply the live load onto the roof. Okay. Okay, so that is how you're going to apply the loading. Okay, so this is not how you're going to apply, but rather this one. Okay, this is in accordance with the ASCE specifications. Okay, kasi horizontal yung application ng load natin, horizontal projection. So if you're going to apply that to the roof, okay, if you're going to apply it to the roof, ganito na guys yung magiging kakalabasan niyan. Okay? So, ito kasi yung specs ng ASCE. Now, transfer that to the roof. Ayan na siya. Okay. Okay? So, yun lang naman. Okay, going back to the presentation, we have okay. So I hope you can see the presentation now. Going back. Hirap naman mag-alternate. Okay. So we always have to remember, ano naman tong R1 and R2 na ito? Okay, ano tong R1 and R2 na ito? Okay? So yung ating R1 and R2, okay? So yung reduction factors natin R1 and R2, those are the reduction factors. It is actually equal to this value. Okay, if your tributary area is less than or equal to 2,200 feet squared, okay, that is 1. But if your tributary area is greater than 200 but less than 600, that is, I think gagawin yung formula, okay? And then 0.6 naman kapag yung tributary area ninyo is greater than or equal to 600 feet squared. This is in terms of the British units, guys, ha? Okay. Now, kapag ang inyong tawag dito, ang inyong F ninyo, the number of inches of rise per foot, okay? So we're actually pertaining to the slope, okay? So if the slope is less than or equal to 4, okay, you're going to use 1. And then if your F is less than or greater than 4 but less than 12, you have to use this. Okay, so ito yung mga conditions and then you just have to follow yung formula. Anyway, ang magiging complicated lang naman dyan is yung, kumbaga, medyo matrabaho lang dyan itong pangalawang mga formula natin kasi meron silang desired na empirical value. Okay, so that's 0.001 of 80. That's 1.2 minus mga ganyan. Whereas yung ating first and third conditions is, ayun nga, no need for computations anymore. Okay? So, ito yon 80 is the tributary area. And then yung inyong F, okay, the number of inches of rise per foot in SI, F equals 0.12 multiplied by the slope, okay, with slope expressed in percentage points. Okay, and for an arc dome, F equals rise to span ratio multiplied by 32. Okay, pero we don't have arc naman, arc or dome. Okay, it's always the pitched roof. Okay. Okay. So, meron tayong crane loads. Okay, yung mga crane loads natin, wag na natin siya masyadong discuss, guys. Kasi we won't be having cranes naman. Crane loads are just ganon. Are just, parang in-introduce lang siya dito for the sake of those having a construction. Okay, construction. Kasi di ba na, especially kapag high-rise yung building, of course. Pag high-rise yung building, you have crane. You have crane loads. Okay? So, pasadahan na natin yung crane loads na yan kasi we will be really using that one kasi yung designs natin are actually, kumbaga, assume na natin na nagawa na siya. Okay? Okay. Meron tayong garage loads, guys. Okay, ito, garage loads, passenger vehicle garages. If you will be having a garage later on in your building, okay, floors in the garages of or portions of a building used for the storage of motor vehicles shall be designed for the uniformly distributed live loads of table 4.3-1. So we're always going back to 4.3-1, okay? Or the following vehicles accommodating not more than 9 passengers. Okay? So if you have a vehicle, if you have a bus, mga ganon, hindi siya applicable kasi yung bus niyo, it will carry more than 9 passengers. Okay? So dapat limit lang natin yung vehicle. Maybe a van will do. So yung inyong live load, concentrated live load should be 3,000 pounds. 13.35, okay? Acting on an area of 4.5 inches by 4.5 inches, okay? Since it is a concentrated load, hindi naman natin masasabi na at point lang siya, nagbigay na lang siya ng particular area, okay? In which that concentrated load should act, okay? So next is mechanical parking structures without slab or deck that are used for storing passenger vehicles, okay? So 10,000 kilonewton per wheel naman yung gagamitin nating live load, okay? Remember, sa mechanics of deformable bodies, yung mga live load, yung moving loads na yan, that is actually taken from, or this section is taken from mechanics of that live load or moving loads, okay? Kasi yung wheel natin ang kina-consider. Okay, so meron tayong concentrated load na 10 kilonewton. Okay, so whichever will, if this number 1 and number 2 will be satisfied, okay, will not be satisfied rather, you're going to use table 4.3-1. Okay, you will be using table 4.3-1. Okay, so kailangan i-satisfy muna natin itong 1 and 2, okay, before kayo proceed sa table 4.3-1. Okay. Next, truck and bus garages. Okay. So yung bus and truck loading natin is in accordance with the AASHTO LRFD bridge design specifications, which will not be tackling anymore. Okay, kasi that's a separate professional practice na. Okay. Helipad naman. Sa helipad, wag na natin itong masyadong in-depth kasi hindi naman tayo maglalagay ng helipad. Okay? Poor lang tayo, guys. Okay? So, yung ating helipad, okay, meron siyang specific section dito, pero other than this section, okay, kung wala man dito yung live load or yung uniformly distributed live load na nasa-satisfy ng inyong helipad, you have to consult the authority having jurisdiction. Okay? So kung hindi man siya na-state dito, wala siya sa conditions na to, well, you have to just consult the experts with regards to the helipad load. Uninhabitable attics. Okay, so meron tayong mga uninhabitable attics din. Okay? So, in residential occupancies, inhabitable attic areas without storage are those where the maximum clear height between the joist and the rafter is less than 42 inches. Okay? So, yun yung tinatawag nating, ang tawag dito, yun yung tinatawag nating uninhabitable uninhabitable attics. Okay? Yung mga attic na yan, mga small spaces lang yan doon sa roof natin actually, below the roof rather, underneath the roof. Okay? So yun yung mga attic, uninhabitable. Uninhabitable if yung height ng attic ceiling natin from the ceiling to the roof is actually less than 42 inches, okay? Or that is 1.067 meters, okay? Or where there are not two or more adjacent trusses with web configurations capable of accommodating an assumed rectangle of 42 inches, okay? In height by 24 inches width, okay? Or greater within the plane of the trusses. So if that attic is somewhat not occupiable by a person, yun na lang. Meron kasi tayong ganun, guys. Meron tayong mga ganung attic, guys, no? Meron kasi yung iba na sobrang laki ng attic nila na pwedeng mong pagtambayan talaga. Pwede ka pa maglagay ng isang bedroom doon. Pero in this section, guys, na sinasabi natin uninhabitable, ito yung kumbaga ginagawa lang storage yung mga attic nila, okay? So hindi talaga kayang mag-fit ng isang tao doon. Okay? So that is your uninhabitable attics, okay? So yung gagamitin natin is the live load in table 4.3-1 need not to be assumed to act concurrently with any other live load. Okay, so we're going to we're going to use yung table 4.3-1. Okay, pero hindi there's no need for us to apply any other loading other than what is specified in 4.3-1. Okay, so parang ganun siya since hindi naman siya hindi naman siya habitable, okay? Walang masyadong live load doon, walang moving loads, okay? It's just storage, okay? There's a minimum provision lang for uninhabitable attics, okay? And that is stipulated in 4.3-1. Okay, so ito yung uninhabitable attics with storage, okay? And then ito yung mga provisions niya, okay? For sure naman, we won't be having attics later on in case study kasi that will be roof deck, okay? Roof deck lang siya, kumbaga box type lang talaga siya. We won't be having such tawag dito, slanting na roof, yung gable na roof, mga ganyan, mga pitch, mga ganun, okay? So it's just roof deck lang. Huwag na natin gawing complicated pa. Okay? So, hindi naman tayo magtatras doon for sure. It's just a buhos na lang. Okay? Let's make it ganun na lang yung requirement. Okay? Let's make it a requirement na flat roofing lang tayo. Okay? And then buhos. Okay? So, slab lang din yung sa taas. Okay? So, library and stock rooms. Okay? So, if you have like a library, okay? So the live loading for library stock rooms provided in table 4.3-1 applies to stock rooms, okay? Stock room floors that support non-mobile double-faced library book stacks subject to the following limitations, okay? So the nominal book stack unit height shall not exceed 90 inches or 2.29 meters. Yung taas ng nung bookshelf mo, guys, the library, okay, it should not be 2.29. Okay, the nominal shelf depth shall not exceed 12 inches or 0.3 meters. Okay, so yung taas ng each shelf ng inyong stack should not be greater than 0.3 meters. Okay, so yun yung pinaglalagyan mo ng libro, guys. Okay, yung doon mo sinusuksok yung libro mo, yun yung shelf ninyo. And then parallel rows of double-faced book stacks shall be separated by aisles not less than 36 inches or 0.914 mm wide. If you're going to the library, di ba, may magkaharap na book stack doon, okay? Yung space between the two stacks should be 0.91, okay? mm or 0.91 meters, 0.914 meters wide, okay? Those are the conditions in order for you to apply yung loading ng 4.3-1, okay? Seating for naman tayo. So ito yung mga seating for assembly uses. Of course, uh, these are specific for conventions, mga ganyan. As long as there's an arrangement of seats, okay, in in a dome or in a function room, okay, ito yung magiging provision natin for vertical live loads, okay? So, gagamit pa rin tayo ng table 4.3-1, okay? The design, pero yun nga lang, the design shall include horizontal swaying forces applied to each row of the seats as follows. So, 24 pounds per linear feet, magdadagdag tayo ng 0.35 kilonewton per meter of seat applied in a direction parallel to each row of the seats. Okay? So, kumbaga yung live load mo will be distributed 0.35 in each seat. Okay? Then, 0.15 kilonewton per meter naman, okay, applied perpendicular to each row of the seats. Okay? So, kumbaga parang chess piece yung application natin. Parallel to the seats, okay, 0.35. Perpendicular to the seat row is 0.15. Okay, the parallel and perpendicular horizontal swaying forces need not be applied simultaneously. Okay, so pwedeng hindi din sila sabay na i-apply. Okay, pwedeng mauna muna yung 0.35 followed by the 0.15. Okay, then we have sidewalk, particular driveways, and ano to? Tards? Tards ba? Tama ba? Yards, rather. Duling ka, girl. Okay. Yards with subject to trucking. Okay, so yung uniform live load ng sidewalks, vehicular, or driveways subject to trucking, okay, shall also be considered where appropriate in accordance with an approved method which contains provisions for truck loading. So normally, ang ginagamit natin dito is yung LRFD bridge design kasi AASHTO na kasi siya, guys. Okay, hindi na siya ASCE, it's part of the AASHTO na. Okay, so concentrated live loads naman provided in table 4.3-1 shall be applied on an area of 4.5 inches by 4.5 inches. Okay, so may concentrated area tayo. Ay, may concentrated load tayo. Okay, for sidewalks. Anyway, wala naman tayong sidewalks later on sa inyong design. It's just a plain RC frame. Okay? So may stair treads din tayo. Concentrated load on stair treads provided in table 4.3-1 for stair and exit ways and for stairs in 1 and 2 family dwellings shall be applied on an area of 2 inches by 2 inches. Okay? And is to be applied non-concurrently with the uniform load. Okay? So, yung inyong concentrated live load should be applied to every step, guys. Okay? When you say stair treads, it should be it's actually the steps of the stairs. So, in every 2 inches by 2 inches, okay, stair tread, mag-a-apply kayo ng concentrated load na in accordance with 4.3-1. Okay, in every thread yon. So for example, yung thread ninyo, sabihin na natin 4 inches by 4 inches. So ang i-apply yung concentrated live load is dalawa. Okay, dalawa. Kasi ang area ng concentrated live load is just applied on a 2 inch by 2 inch area. Okay. So solar panel loads naman tayo, 4.3-1 lang din tayo, only that the roof live load need not be applied to the area covered by solar panels where the clear space between the panels and the roof surface is 24 inches. Okay, if you already have a solar panel, okay, on your roofing, okay, hindi mo na kahit wag mo nang i-apply, guys, yung table yung inyong loading sa table 4.3-1, okay, na may solar panel system dead load. Okay, kahit hindi mo na yun i-apply, guys, as long as yung clear space between the panel and the roof surface is 24 inches. Okay, or that's approximately 0.6 meters or less. Okay, so the uniform and concentrated roof live loads specified in table 4.3-1 without the solar panel system present. Okay, so you can apply table 4.3-1, okay, for the solar panel system dead loads, except when the space between the solar panel and the roof surface is 24 inches. Okay, 24 inches. So, kahit wag ka na mag-roof dead load, diretso ng solar panel system dead load. Okay? Ito na yung i-apply mo. Pero kapag ang space between the solar panel and the roof is 24 inches or less, mag-a-apply ka pa rin ng uniformly distributed na dead load and then yung solar panel na dead load. Okay? Otherwise, kung medyo malayo, you can just apply yung solar panel lang. Okay? So yung load combination natin for the roof systems are provided in chapter 2. Okay? So meron tayo niyan guys dun sa may week 1. Okay? Yung mga LR doon kung ano yung factored loading niya. And then open grid roof structures supporting solar panels. So structures with open grid framing and no roof deck or sheeting supporting solar panel systems shall be designed to support the uniform and concentrated roof live loads specified in table 4.3-1, except that the uniform roof live load shall be permitted to be reduced to 0.57 kilonewton per square meters. So kung walang covering yung roof ninyo and it's just open because yun nga, meron kang solar panel, okay? Pwede kang mag-reduce ng uniform live load mo sa roofing, okay? Ng 0.57 kilonewton per square meter. Okay, anyway, wala naman tayong magiging live load, tawag dito, wala tayong magiging, tawag here, wala tayong magiging solar panels later on. Okay, tulad nga sinabi ko, let's not make things complicated anymore. Okay, so meron lang tayo tawag dito, dead loads and live loads lang. We won't be having like solar panels, mga ganun, garages, mga ganyan. Unless meron kayong garage guys sa roof ninyo. Okay? So ito yung mga consensus standards and other reference documents. So meron tayong AASHTO. Okay? If you want to learn more about the tawag dito, if you want to learn more about the design specifications for trucks, buses, and other related systems, you have to consult yung AASHTO LRFD bridge design specification. Okay, that's for state highway and transportation officials. Okay, for moving loads yan guys, trucks, mga ganun. Then ASME naman, American National Standard Safety Code for elevators and escalators. Kasi kanina hindi naman natin nasabi. There was a provision on the elevator, mga ganun, escalator, pero hindi na natin siya kina-cover sa ASCE. Okay? Kasi separate code na siya. Okay? So ASME A17 na yun. So if you want to know more about this, consult nyo na lang yung references na ito. And I believe that ends the discussion for week 2. Okay, so any questions, clarifications, guys? Kahit pa paano naman may naintindihan kayo, di ba? Kahit pa paano. So ang hirap kasi guys, intindihin talaga ng ASCE ng code. Okay, ng code natin when we are not doing it hands-on. Okay. When we're not doing it hands-on, mahirap talaga siyang gawin or mahirap siyang intindihin. Okay? Pero kahit paano sana, meron naintindihan niyo naman yung ibang concept. Did you understand some of the concepts behind the code, especially yung mga terminologies? Kahit yung terminologies lang guys, okay lang. Kasi when you will be having your quizzes or exam naman later on, open naman yung ASCE specifications natin. Kasi walang tao na magde-design ng hindi ino-open ang building code or ang code natin. Okay? So, any questions, clarifications? Wala naman? Are you all good now with your research critic? Ay, ko na. Wait lang, Daphne. Questions, clarifications, guys, sa may, ang tawag dito, sa ating discussion, research critique. Wala naman. Okay. Anyway, that will be all for today. So tomorrow, next week, guys, Wednesday, Wednesday may discussion tayo ng week 3. And then by Thursday, you will be having your first quiz and first sit work. Okay, so the first quiz and first sit work will just revolve around week 1 and week 2. Open naman yun, guys, so don't worry. So it will just be a few technicalities with regards to the code and yung mga definitions. Okay? So kung wala na kayong problem, wala na kayong question, you may leave the bridge. If you do have questions, you may stay.
Thank you, sir.
Thank you, sir.
Bye, sir.
Thank you, sir. Bye, sir.
Bye na po.
Thank you, sir.